Hi everyone, this is Motahareh. I'm a Ph.D. student at Industrial and Manufacturing Systems Engineering at ISU, and today I'm going to talk about my research, which is supply chain design for chemicals from biomass. CO2 emissions from human activity are causing climate change, and to reduce the carbon footprint, the chemical industry will need to switch to renewable energy and replace petroleum with biomass. So we're going to have greener materials with the help of greener energy. And electrochemistry has shown promise for producing chemicals from biomass. The objective of our project is to understand and address the scientific and technological barriers to an electrochemical process for the distributed manufacturing of high-value monomers and performance advantage polymers from biomass. To do so, we need to design a proper supply chain from the very first part, which is related to biomass cultivation, into the very end part, which is related to demand zones in the market. This is a simple network for our supply chain. In each step, as you can see, we need to define our known parameters and we need to define our decision variables. For example, in cultivation sites, we know about the cultivation cost, harvesting cost, and maximum available lands. And we need to decide about land devoted to cultivation and amount of harvested biomass. So we need to decide about devoted lands for biomass cultivation, the amount of biomass harvested in cultivation sites, the amount of harvested biomass transported from cultivation site to pre-processing facilities, amount of densified biomass transported from pre-processing facility to conversion facilities, and amount of chemicals produced in conversion facilities and transport to demand zones. And also we need to decide about location of each facilities. And our objective here is to minimize the total annual cost, which would categorized into fixed facilities cost, biomass production cost, pre-processing costs, chemical production cost, and transportation costs. Of course, in each step, we will face some constraints which need to be taken into account. For example, in cultivation sites, we need to respect limits on available land and the limit on yield in each time stage, the conservation of biomass, and we should pay attention to the inventory balance at each time stage. Our next step would be formulating a deterministic optimization model and then adding uncertainties in order to make it more realistic and then finding a solution procedure to find our model.